Hello and welcome to discussion 5 for CS61B. Today we're going to be talking about iterators and iterables and some other stuff that's kind of leftover content. So first things first, let's get through announcements. Midterm 1 is this Wednesday. Lab sections on Wednesday will be converted to office hours for midterm materials. So if you have a lab on a Wednesday normally, please go to a Thursday or Friday lab. Homework 1 is going to be due next Monday, and there will be live lecture this Wednesday. Time for some content review. The first thing we're going to talk about is subtype polymorphism. It sounds like a really fancy word, but really we're just talking about something that you already know and giving it a name. Subtype polymorphism is the name for the fact that we can basically, from what we've seen before, if we have an animal class that's subtyped as dog, maybe cat, a function that takes an animal can also take in a dog or a cat. And this is really powerful. The reason is, if we had some other class and we want to run some function on all animals, animal A, if we didn't have the ability to put instances of subclasses in places that are defined as holding their superclass, we would have to create a separate function for each subclass and treat them all differently, even if we are altering a variable that all of them have in common by virtue of being subclasses of animal. And so this is a really powerful feature of Java. It's really useful, and this is why we talk so much about inheritance in this class. Subtype polymorphism is not just limited to classes, it's also usable with interfaces. So an example would be comparable, which is an interface that allows us to compare items, and it returns an integer that's either negative, 0, or positive. And so let's say we are creating an array that's a comparable array. And so this means if it implements comparable, then this array has a compare_to function. And let's say within that compare_to function, we want to run compare_to on each individual of the array against each individual of the other array. And so what we do is we say that our generic type also has to implement comparable. And this means that any type of variable, any object, so long as it's comparable, is allowed to be our generic type. Next, we can talk about exceptions real quick. Again, this is something that you've already been seeing a lot of. We're just going to kind of codify and name that knowledge. So exceptions are used to pause the code and be like, something's going wrong, something's happening that should not be happening. An example that you've definitely seen, I've definitely seen it, is null pointer exceptions, which appear when you try calling something on a variable that contains null. So if we have some sort of variable x and there's secretly a null in there, and we call .equals, this breaks because null does not have a .equals function. There are no functions that belong to null, and so you get a null pointer exception. Same with the index out of bounds exception, which I'm sure you've also seen, especially working on ArrayDeck, where you try accessing an index array, an index of an array that is larger than the size of the array. So we have those. There's a bunch of others. You try dividing by 0, you might get an arithmetic exception, etc. And the way they are thrown is using a line of code that looks like this. You may not have seen it, but it exists somewhere in your computer that when the things above happen, those exceptions get thrown. And you can throw your own exceptions that you can name whatever you want by using this type of code. So you just write throw new whatever exception, and then this is the error message that comes up. An example of the error message would be for index out of bounds exception. I'm pretty sure the error message is something like you tried to access index 5 on an array of size 4. And so the goal of that error message is to give you a little more information on what exactly went wrong. So that's how you throw an exception, which will break your code, which will stop it from continuing. You can also catch exceptions. And what catching does is it tells your computer, okay, I acknowledge that this exception can happen, it might happen. And so if this happens, do this thing instead, but don't stop, don't pause. Keep going as if it was fine. And so this is useful in places like, for instance, when you're trying to open up files, exceptions can happen there sometimes no matter what you do. And so you might want to catch an IO exception, which is like telling your computer, oh, I tried to open this file and something went wrong. And then you tell it an alternate thing to do to fix that problem and then move on without causing issues. So try, this is where you put the code that might error, and then catch is where you put what you do when that error occurs. Moving on, we're going to talk about iterators and iterables. So from last week, we learned about interfaces, and both of these are interfaces. Iterator is an interface, which is not, I don't think you guys have actually really worked with an iterator yet, but iterators are the objects that can be iterated through, essentially, and they have two functions that they have to define. There's Boolean has next, which will return true if there is another element to be returned, and false if there isn't, and next, which returns the actual next object if there is one, and throws an error if there isn't, usually. The next interface is iterables, which are objects that can produce an iterator. You've seen a lot of iterables already. Linked lists can be iterables, arrays can be iterables, decks, you can make them iterables. Like, these are just the types of objects that you think of when you think of objects that you can iterate through. They actually produce an iterator, which is what this function does. It returns an iterator of type T, which we define up here. When we implement the class, we'll write, I can write implements, implements, iterable, and then we'll write whatever type. So if we're going to iterate through a bunch of strings, we can do string, and then that's what we're going to return in this function. And so once we have that, this produces one of these, and then that's what we iterate through. Great. Now we're going to move on to the worksheet. This first problem is just a quick review of what I just said, because we're going to be building this cool like office hours queue iterator today. So real quick, let's just remind ourselves what the functions for both interfaces are. I'll give you a couple minutes to think about it, and then we'll reconvene. Great, okay, welcome back. So the first thing we're going to do is iterable. So iterables are the ones that produce an iterator. So for this, there's only one function, which is iterator. And don't forget, it's of type T specifically. And the function is also called iterator. And just like that, that's our function for iterable. Now our functions for iterator, there's two of them this time. Again, like I just said, there's the first one, which tells you whether or not you have a next element to pull from, and then the function that actually returns that next element if there is one. So we have Boolean has next, and T next. And again, we're going to be returning the same generic type we define when we implement the class. Okay, so now we've done that. We already talked kind of about the difference between iterator and iterable, but just to really drive it in, iterators are the actual object we iterate over, and iterables that are objects that produce an iterator. Okay, the first real problem. So in this problem, our goal, in this problem too, overarchingly, our goal is to create an office hours queue that is iterable. And so first we are given this block, which is our office hour request. It's a single request, and if you look kind of closely at it, you have a description, you have a name, and you have next. So this is kind of like a linked list of sorts, where each item has a name and a description, and then also a pointer at the next item in the queue. So the first thing we're going to try to build is an office hour iterator. And so the goal of this is to implement an iterator that returns office hour request objects, but only if they have good descriptions. And the way we define a good description is by this function right here. It doesn't really matter what it says, but if you're curious, it's just saying whether or not the description is empty and whether or not the description is greater than length 5. I'll give you a couple of seconds to think about it. Okay, let's reconvene and talk about it. So the first thing that we have to do is fill in this top blank over here about what we're implementing. Implements. And like I said before we started, we're creating an iterator this time as opposed to an iterable. And inside these brackets, we're going to put what we will return at each time step. And so in this case, it'd be office hour request. Now that that's out of the way, we can move to the constructor. For the constructor, we are given this office hour queue, which, like we've said before, is essentially like similar to the int nodes that we've built before. It's the first element of a linked list. So all we have to do is set cur equal to queue. Great. So now that we've done that, we can tackle the bigger functions. We can first tackle has next. So first of all, don't forget, always write at override. And the reason we do this is not because we have to. Our code will technically compile just fine without it. But it's good because it prevents us from writing code for making typos and then having weird inheritance problems later on that are really hard to debug. So we have at override, public, boolean, has next. If you're wondering, can I make this function private? The answer is actually no, because all interfaces by default have their functions as public. By default, the interface's has next function is already public. And when you override a function, your function has to have greater access or equal access to the function it overrode. And so because the interface's has next is public, ours has to be as well. It won't work if it's not. If the interfaces was protected, package protected, or private, we could make it public, or we could make it whatever the interfaces one was as well. So we have public boolean has next. And the first thing we're going to make sure is that we have our base case essentially, which is while cur isn't equal to null. So long as we haven't hit the end of our list and we haven't hit a good description, is good cur dot description. I never leave myself enough room on these slides. Is good cur dot description. We will iterate through our list. And once we hit either the end of our list or we hit a office hour request that has a good description, we can return it. So if cur equals null, then obviously there's something left to iterate through, so we will return false. And otherwise, we will return true. Now this is just our hasNext function. We also have to implement our next function. And so I'm going to do that over here on this side because I'm running out of room. It's still part of this OH iterator class. So again, can't forget at override. And then we have public. And remember, we have our generic type over here as office hour request. We've defined our generic type to specifically be office hour request. So we have to return our OH request. And then it's called next. And then the first thing we check is if there even is something to return, because if there isn't, then we have to throw an error. So we say if as has next. If it doesn't have next, then we throw new no such element exception. If you look at the Java doc for the iterator interface, it specifically says that next may throw the no such element exception, which is why we pick that over any other exception. It also just fits this what's going on the best. So now that we've made sure that there is in fact an element for us to return, we have to pick that element out of our queue. So OH request r equals current. And then we basically move our pointer in the linked list down by 1 so that next time, we can check the next element. Dot next. And then we just return R. Great, so our iterator class is done. Now we're going on to 2B, where we create the iterable that creates this iterator. So we're creating the actual office hour queue this time, which will allow us to process office hour requests with good descriptions. We will take in an office hour request object, and our only function will be the one that we have to implement because we're implementing iterable. So I'll give you guys a couple minutes to think about it, and then we will reconvene. Okay, welcome back. Let's talk about it. So the first thing, like I said before we started, was we have to implement iterable up here. So I'll get that out of the way. And so what type of iterator are we returning? We're returning an office hour request iterator. So that's what we put in those brackets. We need a variable to keep track of our queue, or we'll lose it after the constructor is over. So we'll need our OH request queue. And now we can set this.queue equals queue in the constructor. And now we have to actually implement our iterator function. So again, at override, and then we have public iterator of type OH request. And then our function's name just happens to also be iterator. And then we return a new office hour iterator. We already did all the hard work of figuring out how to set up the actual iterator here. So all we have to do is construct this iterator and then return it. So we return a new OH iterator with our queue. And that's it. That is our entire iterable function. So the last part of question 2 is we have a main function with an office hour queue, and the goal is to create an office hour queue object and then print out the names of all the people with good descriptions. So I'll give you a minute to think about it, and then we'll reconvene. Okay, welcome back. So the first thing that we're going to do is create our new office hour queue object. So we will do that right here. I'll just call it queue. And don't forget, we're going to put in the first object of our linked list, which happens to be this guy, into here. And now we're going to print out each name if the person has a good request. Again, we don't have to deal with figuring out all that because our iterator does it for us. All we have to do is request O, and then put Q here, and this for each loop automatically calls the iterator function for Q, so we don't have to do that manually. It'll already pull the iterator out and then iterate through it. So all we have to do is system.out.print line o.name. And that's it. That is our main function. So now that we've done that, we can finally move on to question 3, our last question. So all we have to do for this problem is something very similar to our old office hour iterator, except this iterator skips the immediate request that follows a request with the words thank you in it. So if you have requests like this, and this one contained the word thank you, you would just skip this request and move on to the one after. So this one, if you notice here, the keyword is extends instead of implements. Don't forget that. And I'll give you a couple seconds to think about it. Okay, welcome back. Let's get this done. So the first thing we have to figure out is what does it extend? So remember, this is a type of office hour iterator. It just is this very specific type because it has an extra condition on it, basically. It still has to abide by the rules of the thing, like the actual request has to have a good description and stuff like that. There's just this extra sort of thing on top of that. So we're going to extend is iterator. And in our constructor, all we're going to do is call our superclasses constructor on queue. So it sets up all the variables for us. And that's done. Now we're only going to have to override one function in this, which is next. So we'll do @override public request next. And so first we'll get the results from calling next on our superclass. So we get result equals super.next, which will handle all the throwing errors and stuff for us all the way already. And now we're going to handle our extra condition. So we'll say if, first of all, cur doesn't equal null, as in if we're not already at the end of our list, and if cur.description contains thank you, then we're just going to skip over this node and set cur equals to cur.next. And the reason we do cur.description contains instead of result.description contains is that in this problem, the reason we skip over this is because it's a repeat of this. The same effect could be reached by doing result.description contains. And then we just return result. And that's it. We are done with this worksheet. I hope you guys have a great week. Good luck on the midterm. I hope I see you guys in discussion next week. Bye.